Okay, this is the second video on lesson C-5. This video we'll be talking about arcs and angles formed by tangents, secants, and chords. This was basically the second day that we did on this lesson in class. Okay, so when tangents, secants, and chords intersect inside a circle, on a circle, or outside a circle, special relationships exist between the angle and arc measures formed. So as you saw, we have three different situations here. Figure 1, we'll be dealing with what it looks like when these two intersect inside a circle. The intersection on the circle looks like this in Figure 2, and Figure 3 shows us their intersection outside the circle. And we'll be dealing with them. We'll be breaking these problems down into these three types today. So first we'll start with intersections inside the circle. This tells us that if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measure of the intercepted arcs. So you see we have angle 1 and 2, the blanks right here. We have our drawing right here. Notice whenever we have things intersecting inside the circle, we've got actually 3 angles right here, right? But because these are vertical angles and that are formed when we in this situation, we know these two angles, 1 and 3 in this case, would be congruent, and then 2 and 4 are also congruent. So we just have to really need to cover angle 1 and angle 2 in this case because of those facts. Those are vertical angles. So it says the measure of angle 1 will be half the sum of the measures of the intercepted arcs. So for angle 1, the intercepted arcs would be AD and BC. Those would be the two arcs that we're looking at. It's intercepted arcs, and the way you can find these is this. I look at it as it's the arc that is inside the angle, okay, formed by those endpoints, and then over here the same angle BC is also inside that angle. So our formula for this is for the measure of angle 1, I guess, would be that it's half of the sum of those two measures. So we'll say 1/2 times and then you just add up the two measures of the intercepted arcs. So I'll say here the measure of arc AD, which is one of them, plus the measure of arc BC, which is the other one. And then we'll just take half of that. Basically, all we're doing here is we're taking this measure and this measure, adding them up, and then you're dividing by 2 to get the measure of the angle. So similarly for angle 2, AB and DC would be the arcs. So this will be 1/2 times the measure of arc AB plus the measure of arc DC. Alright, and those are our two formulas we'll use for this stuff. So let's solve some problems. Okay. So number 13, find the measure of angle AED. Okay, AED is right here, and here's its vertical angle, of course. So those are congruent. And then our two arcs that are intercepted are given to us to be 45 and 109. So the measure of angle. Actually, let's do it like this first, and then we'll show you a different way you can think about it. Remember, so our formula tells us that all we're doing is adding up its two intercepted arcs and dividing by 2. So first I'm going to do is add those two arcs up. 45 plus 109. Let's see. 45 plus 109. That is 154. And then we'll take 154 divided by 2. And that's equal to 77 degrees. So the measure of angle AED is equal to 77 degrees. And we're finished. Now let's see it again. This one wants us to find the measure of angle YWX. That's this angle. However, I don't know that angle. I do, however, realize that angle YWX and angle YWV are supplementary because they form the straight line. So I can find this angle by what I'm using the formula over there, and then once I have that, I do 180 minus this angle to get the angle I'm looking for. So that's my plan for this one. So the measure of angle YWV is 1/2 of the sum of those two, so 43 plus 81. Okay, and this is going to be, let's see, 43 plus 81 is 124. Then we divide by 2. That gives us that is equal to 62 degrees. Okay, so 62 degrees right here. Now, to get the angle I'm looking for, which is the measure of angle YWX, that's just going to be 180 minus 62. So it's equal to 118 degrees. And that's that one. Now, number 15, so the first two we just found the measure of angles in here. Now we'll be finding the measure of arcs in the next two. Find the measure of arc CDE. Okay, that's right here. I don't know it. I'm going to call it X. Now I can plug into my formula. I have the angle from the inside, and then I have the other intercepted arc. So we'll plug into our formula. Our formula starts with our angle on the left, so that's why I'll have 128 on the left over here. That's going to be equal to 1/2 of the sum of our two arcs, 73 and X. Okay, now when I'm looking at this, I want to get rid of this 1/2. I can do that by multiplying both sides by 2. So when I do that, 128 times 2 is 256. Okay, so the whole reason for multiplying this half by 2 was to get rid of this 1/2, because 2 over 2 is just equal to 1. So all we'd be left with on the right side would be 73 plus X, which is our intention here. Now, to solve for X, I'm just going to subtract 73 from both sides. So 256 minus 73. That's going to give me 183 degrees. So that is the measure of angle CDE, which is what I was trying to find. That's good. So the measure of, excuse me, not angle CDE, arc CDE. The measure of arc CDE is equal to 183 degrees. Okay, and let's do similarly for QT right here. This is the arc I'm trying to find right here. Okay. However, I need angle RUS to do this, but I have this one, and I know it's supplementary to angle RUS. So we're going to do 180 minus 79 it's 101. So that tells me that this angle right here is going to be 101 degrees. And now I can do what I did in P15. So I've got 101 is equal to 1/2 of the sum of those two arcs, X plus 95. Multiply both sides by 2, you get that this is 202 is equal to X plus 95, and then X is going to be equal to 202 minus 95, which is going to be 107 degrees. So the measure of arc QT is 107 degrees. All right, moving on. So now we've dealt with intersections inside the circle first. Now we'll deal with intersections on the circle. If a secant and a tangent intersect at the point of tangency, okay, so it has to be a secant and a tangent. If they intersect at the point of tangency, then the measure of each angle is equal to half the measure of its intercepted arc. So look at our picture down here. You have a tangent line, and then at that point of tangency, you basically have a secant drawn out, okay, and that they're intersecting at that point of tangency, and we have angle 1 and angle 2 that are formed. They are half the measure of their intercepted arcs. So for angle 1, it would be arc AB. Angle 2 would be arc ACB. Okay, you're just going to take half of those. So we'll say measure of angle 1 is equal to 1/2 times the measure of arc AB. And then for angle 2 would be 1/2 the measure of arc ACB. Okay, so notice how those two angles, there's only two along that straight line, so we know they're supplementary. So if I knew the measure of angle 1, I could easily find the measure of angle 2. Similarly, notice that the two arcs we have are the only two arcs on the circle. So if I know the measure of arc AB, I can easily find the measure of arc ACB by doing 360 minus whatever that measure was. So keep that stuff in mind as we solve these next few problems. Okay. P17 says to find the measure of angle DEG. So angle DEG, let me get some different color marker here. We'll go a little brighter. Okay, cool. So the measure of angle DEG. DEG is this angle right here, okay? And then we are given the intercepted arc EHG. That's the one for this angle, so that makes this problem pretty easy. The measure of angle DEG is just going to be half of that, so it's 308 divided by 2, and that's going to be equal to 154 degrees. That's our answer for this one. P18. We want to find the measure of angle DBC. Okay, so here's what I'm going to do. I don't know its arc, so I'm going to find its arc first. I know the other half of the circle, the other part of the circle, to be 192. So we'll do 360 minus 192. Okay, 360 minus 192. That's 168 degrees. And that is my arc over here. Now, to get my angle, we'll just divide that by 2. That's equal to 84 degrees. Very good. Moving on. Number 19. Find the measure of arc XY. So what I can find, I don't know that one, I don't know the angle, but I do know the angle of the other arc. So let's find that arc and then subtract that from 360 to find XY. So to find this arc right here, it'll be 151 times 2, which is 302 degrees. Now I'll take that arc and subtract it from 360 to find the measure of arc XY. So we're subtracting from 360. So the measure of arc XY is going to be whatever that is. That'll be 58 degrees. That's our answer here. Next, number 20, find the measure of arc KNM. We're given the angle for this one. Let's find the arc of it. Okay, so 23 times 2. So it's 46 degrees. So arc KM is 46 degrees. Now we'll do the measure of arc KNM. It's just going to be 360 minus this 46. And that'll give me my arc that I want. 360 minus 46 is going to give me 314 degrees. So that's our answer. And that is intersections on the circle. Now our last part right here will be intersections outside the circle. And for that we have basically 3 different types you might see, okay? You might see 2 secants intersecting, a secant and a tangent intersecting, and then 2 tangents. And we'll talk about the angle form whenever you do that, okay? If secants or tangents intersect on the exterior of a circle, then the measure of the angle formed is equal to half the difference of the measures of the intercepted arcs. So still half of something, but this time we'll deal with the difference of the intercepted arcs. So angle A is right here, and then our intercepted arcs would be angle BD and arc BD and arc CE. So we'll take the difference, which means subtract, and then we still have to take half of that as well. So it'll be 1/2. So obviously we can see that CE, arc CE will be bigger than BD right there. So that's the order we'll put these in. The measure of arc CE minus the measure of arc BD. Okay, and basically you'll just take the 2 arcs subtract the bigger one minus the smaller one, and then divide that by 2 to get the measure of the angle. It's the same process for a secant and a tangent. Okay, we notice we just have a tangent now, AB, because it only intersects the circle once. So our intersected arcs will be BC and then BD right here. So we'll take half of that still, so 1/2 the difference of those two arcs. The measure of arc BD minus the measure of arc BC. Okay, and then for secants, you can do it the same way with the two intercepted arcs, but there is an easier way to note that if you take your arc, the measure of the arc closer to the angle A, and then those are going to be supplementary, which means that the measure of angle A can be written as 180 minus the measure of arc BC in this case right here. So just take the measure of that arc that's closer, or find it if you can, and then you just subtract that number from 180 to get your measure for your angle. Alright, let's do some problems. Number 21, find the measure of angle KLM. We have two secants here. KLM is this angle right here. So we will subtract those two from 180 and subtract those two, and then we will divide by 2 to get our angle. So the measure of angle KLM is going to be 1/2 of 140 minus 66. Okay, so 140 minus 66 in my calculator gives me 74. Then we take that and divide by 2 to get that the measure of this angle is 37 degrees. Excuse me. That's it. Now let's look at number 22. Alright, this time we have two arcs. One of these is our intercepted arc. Cool. Trying to find BCD, which is this angle. We know some other arc outside. We need to know these two arcs, to be honest. I don't know BD, but I do see that this side of this angle AC right here, it goes through the center of the circle, meaning that makes this whole bottom half right here equal to 180 degrees. So if I did 180 minus 94 minus 67, that would give me the measure of arc BD, wouldn't it? So 180 minus 94 minus 67. That is 19 degrees. So that's the 19 degrees right there. Now I'm going to find the measure of angle BCD, doing what I did in 21. So this is equal to 1/2 of the bigger arc, which is 67 degrees, minus the smaller, which is 19. And we'll put that in my calculator. So 67 minus 19 is 48, and you divide by 2, you get that the measure of this angle is 24 degrees. And moving on to arc measures now. Find the measure of arc QU. Okay, arc QU here. This is this arc right here. Okay, we don't know it, so we'll call it X. And let's solve. We do know the angle that it deals with, and then its other intercepted arc. So you know the angle, 35 degrees, is equal to half of that difference. So we'll take the bigger one, obviously, to be QU. X minus 46. First thing I'm going to do, multiply both sides by 2 to get rid of that fraction. So we'll have 70. And then that just leaves us with X minus 46 on the other side. Add 46 to both sides. X is going to be equal to 116, I believe, yes. Okay, so the measure of QU is equal to 116 degrees. Very good. Now, we have a secant and a tangent here. This time it still will follow the same. We'll find the angle the same way we did with secants. So remember, we kind of talked about that. So all I'm going to do is add these up, divide by 2. I'm going to find the difference. 135 minus 33. So the measure of angle KLM is 1/2 their difference. So 135 minus 33. So 135 minus 33 is 102. Then you're going to divide that by 2. We'll get that the measure of angle KLM is 51 degrees. In this case right here, we have trying to find the measure of angle ABC. We know one of the angles right here, arcs. We know another arc that's not our intercepted arc. Okay, we can find the third one by subtracting those from 360. So 360 minus 88 minus 62. 360 minus 88 minus 62. That's 210 degrees, which that'll go right here then, 210. Now we can find the measure of angle ABC. This can be half of those two angle arcs, 210 minus 62. So 210 minus 62 is 1/48. Then you divide that by 2. You get that angle is 74 degrees. Now for an arc measure, arc EF, they want us to find. Okay, but if I find, I don't know how to do that, but if I'm able to find FH, which I am, then once I find FH, I can subtract FH and the other one, EH, from 360, and that'll give us the measure of arc EF. Okay, so right here, we're going to call this X for right now. So 77 is equal to 1/2 of the 191 minus the X. Okay, multiply both sides by 2. 77 times 2 will give me 154. This is equal to 191 minus X because that 1/2 is now gone. I'm going to add X to both sides and then subtract 154 from both sides. Okay, that'll give me X over here because X was negative, so I want it to be positive, so I brought it over to the other side. And then 191 minus the 154 will give us that that arc measure is 37 degrees. So to find the measure EF, we're just going to subtract the other two arcs from 360. (360) minus 191 minus 37. So that gives me that arc EF is 132 degrees. Boom. Number 27. I've got two tangents here. My shortcut for doing two tangents, you just find that the arc is supplementary, angle is supplementary with the arc. So the arc PR is going to be 360 minus 313. So 360 minus 313 equals 47 degrees. So this is 47. So the measure of angle PQR is just 180 minus that angle, or that measure. 180 minus 47 is 133 degrees. That's my answer. B28 is even easier. To find the measure of angle CDE, we're already given the arc closest to it, so we'll find the measure of angle CDE is just equal to 180 minus 106, which is 74 degrees. Alright, now we move on to the back, which has most of the algebra problems. Hopefully we can get through a lot of these pretty quickly. So it says solve for X, which is the angle right here. We know this is two things intersecting inside the circle. So this angle will be equal to the sum, half of the sum of those two arcs. So we can set this up as following. 3x plus 23 is equal to 1/2 of 75 plus 55. Okay, so 3x plus 23. Put that in my calculator. 75 plus 55 divided by 2. It gives me 65 degrees. Okay, so now we just solve for x. Subtract 23 from both sides. 3x is equal to 42. and then we divide both sides by 3. 42 divided by 3 is equal to 14. So that gives us that x is equal to 14. And then we're finished with that one. Next one we have very similar to this one. Okay, we'll set it up like this. This is the angle. It's equal to half the sum of the two intercepted arcs. So 8x plus 34 equals 1/2 of 159 plus 53. Okay, put that in my calculator. 159 plus 53 is 212 divided by 2, 106. So 8x. Alright, we'll subtract 34 from both sides. 8x is equal to 72. Divide 72 by 8, you get that x is equal to 9. P31. I see these two angles right here. Okay. Okay, no. So we're given this angle, and then we're given this arc measure right here, right? So I know that this angle is going to be half of whatever this arc measure is, right? So I can just do 6x minus 38. We know it's going to be half of 140. So 6x minus 38 is equal to 70. So add 38 to both sides, you get that 6x is equal to 108. So divide that by 6, you get x is equal to 18. Okay, moving on to the next one. Here I've got another one of those like the same. I see I've got this intercepted arc right here to be 14x minus 22, and then this angle that's not that isn't associated with that arc is 23 degrees. What I'm first going to do is I'm going to find this angle right here. Okay, and then I will just solve it similar to the last one. So to get this angle that I marked right there, we'll do 180 minus 23. We see that because they are supplementary, because they're on that straight line. So 180 minus 23 is 157. So, okay, so I know that 2 times this number will give me my arc measure, right? So 14x minus 22 is equal to 2 times whatever that 157 is, okay? Because that's our angle, we want this represented our arc. So 2 times 157 is 314. That's equal to the 14x minus 22. And we'll add 22 to both sides. So it gives you 336. And then dividing both sides by 14, you get that x is equal to 24. Okay, moving on to the next one. So we have an intersection outside of the circle. Okay, and then we have 2 secants doing that. So we know that this angle measure is equal to half the difference of the 2 arc intercepted. That's what we're given here. So 7x minus 1 is equal to 1/2 of the difference. So 161 minus 65. We'll do that in our calculators. 161 minus 65 is 96. Then dividing that by 2, you get it's equal to 48. So 7x minus 1 is equal to 48. Add 1 to both sides. 7x is equal to 49. Dividing both sides by 7, you get x is equal to 7. And that's that one. Okay. Or I think we have one more, excuse me. Okay, so I have a secant and a tangent here. Alright, pretty similar fashion for solving this one, except I'm going to need to find this big arc right here at the bottom. In doing that I can, so far, because I know this is 86, this is 74, so we'll subtract both of those from 360 first. So we'll do that on my calculator. 360 minus 86 minus 74. That gives us 200 degrees. So we have that right here, 200 degrees. So now we'll plug into our formula and set this up. So this angle we're given 4x plus 13 is the angle. So it goes right here. That's equal to half the difference of those two arcs. Okay, 200 minus 86 in my calculator gives me 114. Then divide by 2. That's equal to 57. So 4x plus 13 is equal to 57. I'm going to subtract 13 from both sides. We get 44. Then divide both sides by 4. You get x equal to 11. Alright, that's what we have right there. Moving on to a little bit harder problems, but not too bad, okay? So I've got here, if the measure of angle arc JM is 10x plus 9, so if that's 10x plus 9, we know that in L, arc in L is 28x plus 17. And then the angle here is 16x plus 19. We want to find the measure of angle NKL. Before we can even do that, we need to find x. Okay, so this is what we'll set up. I know the angle 16x plus 19 is equal to 1/2 the sum of the two intercepted arcs, because we're intersecting inside the circle. So we'll add up those two. So 10x plus 9 plus 28x plus 17. It's all inside the parentheses. So let's simplify as much as we can right now. So just 16x plus 19 is equal to 1/2. 10 plus 28 is 38x. 9 plus 17 is 26. So normally I would multiply both sides by 2 to get rid of the fraction, but I'm noticing that both of the numbers we're dealing with inside the parentheses right here are even numbers. So I in fact can take half of those and still have a decent equation, or decent looking equation. So we'll do that. I'll take half of 38, and that's going to give me 19. Still times the x though, and then plus the 13 over here. Sorry, my phone started ringing. Okay, and that's going to give me okay, now we can get the x's. I'm going to bring the x's over to the right side, so I'm going to subtract 16 from both sides. That gives me 3x over here. Then subtract the 13 from both sides gives me 6 right here. So x is going to be equal to 2. Alright, I'm going to plug that in real quick, and then I'll give me the measure of angle NKL. And then in my calculator all together, it gives me 32 plus 19 is equal to 51 degrees. And that's what I've got right there. And that's actually where I'm going to end the video with that. We've done a bunch of questions with it. If you have any questions on how the rest of them are solved on the notes, go ahead and shoot me an email and I can explain further with that. Alright, thanks guys.